Dear students, in today's session, let's learn one more concept of the vectors, which is product of the vectors, that is multiplying two vectors. When we multiply one vector with that of the other, we get either a scalar or a vector quantity. So therefore, there are two possibilities. When you multiply two vectors, either you will get a scalar quantity or you will get a vector quantity. You don't get both. So accordingly, we have two types of vector product. The first one is called dot product. It's represented by A dot B. The other one is called the cross product. The dot product will give you always the scalar, whereas the cross product will give you the vector. So these are the two types of vectors. So that's what we are going to learn today. So first one, the dot product of two vectors. It is also called as the scalar product of two vectors. Why? Because when you multiply two vectors, you will get a scalar quantity. So question again important, has appeared 3 times in the examination. So let's start with the dot product of the two vectors. So the first point is, what is the definition? How to define the dot product? Dot product of two vectors. Dot product of two vectors is defined as the product of the magnitude of the two vectors. Product of the magnitude of the magnitude of the two vectors and the cosine of the angle between them. You can even write like this: magnitude of a vector, we write it as only A and then B cos theta. So what is the definition? Dot product of two vectors is defined as the product of the magnitude of the two vectors and cosine of the angle between them, where theta is the angle between these two vectors. So that is the definition. What is the mathematical form? I have already given the mathematical form of the dot product. A dot B is given by AB cos theta. The value of the dot product depends on the two magnitude as well as the angle between the two vectors. Now what are the examples for this? Work is the dot product of force and displacement. See, this is a vector. Force is a vector. Displacement is a vector. And when you multiply, you will get work, which is a scalar quantity. So that's why in the case of dot product, after multiplying, the quantity what we get is always a scalar quantity. Power is the dot product of the force and the velocity. Force is a vector, velocity is a vector, the product gives you power, and power is a scalar quantity. So what are the example? Work is the dot product of force and displacement, power is the dot product of force and velocity. What are the maximum and minimum values? So let us consider theta is 0. Theta is equal to 0 degree. Now theta 0 means vector A is a parallel to vector B. That means the angle between the two vector is a 0. It will be like this. Okay. A is parallel to B. Theta 0 means a cos 0. What is the value of cos 0? Cos 0 is 1. So therefore, we get A dot B is equal to AB. Next, when theta is a 90 degree, vector A is a perpendicular to vector B. Cos 90 is 0. So we will get A dot B. A dot B is equal to 0. So now tell me, out of these, which is more, which is less? This is more, this is less. So therefore, this is the maximum value. This is the minimum value. Therefore, the dot product of two vectors is maximum when the two vectors are parallel to each other. The dot product of the two vectors is minimum when the two vectors are perpendicular to each other. So this is based on the cos value, cos 0, cos 90. So that table, which again I had given long back, so you need to remember that entire table, only then you will be able to answer whether it's a maximum or minimum. Okay. So dot product is maximum when angle between them is 0 degree or vectors are parallel, and the dot product is minimum when the angle between the two vectors is 90 degree or when the vectors are perpendicular. So, hope you have understood about the dot product. And what is the use of the dot product? When you multiply two vectors, you will always get a scalar quantity. So, that is called the dot product. So, that is why it is also called as a scalar product of two vectors. So, what is the other types of the product? It is called the cross product of two vectors, or it is also called as the vector product of two vectors. In that case, we use the symbol, multiplication symbol. That is how we read it, A cross B. Cross product of two vectors is defined as the product of the magnitude of the two vectors and sine of the angle between them. What do you define? So, that is the definition. Cross product of two vectors is defined as the product of magnitude of the two vectors and sine of the angle between them. When you multiply two vectors, we get either a scalar or a vector. In dot product, we get a scalar quantity, but here we get a vector quantity. But you can see on the side, we do not have any vector because this is a scalar, magnitude is always a scalar. This is also a scalar, this is also a scalar. So, we should get a vector. So, that is why we introduce a unit vector. So, if I now multiply a scalar with a vector, I will get a vector quantity. So, this is how you have to write the complete equation. Okay. We do not write this in the dot product because dot product of two vectors will give you always a scalar quantity. So, to get vector, this is a scalar multiplied by a vector called as unit vector, and now this entire term becomes a vector quantity. So, how do we define cross product? Cross product is defined as the product of the magnitude of the two vectors and sine of the angle between them, and this is the mathematical form of the cross product. So, what are the example for it? So, there are two examples which I am going to give, that is V is equal to omega cross r and A is equal to alpha cross r. This is called velocity, linear velocity. This is called, it is an omega is a symbol, this is called angular velocity. Normally, linear velocity is used when a body moves along a straight line, and the angular velocity is used when a body moves in circular path or when a body rotates about a particular axis, and r is called as the radius vector. So, linear velocity is the cross product of angular velocity and the radius vector. Linear acceleration is the cross product of angular acceleration and the radius vector. So, these are the two examples for the cross product. This is a vector, this is a vector, and when you multiply, you will get again a vector. So, that is what happens in the case of the cross product. So, what are the example? Linear velocity is the cross product of angular velocity and the radius vector, and linear acceleration is the cross product of angular acceleration. Alpha is the symbol, angular acceleration and the radius vector. So, hope you have understood. Next, when it is the maximum, let us consider when theta is 0. Theta 0 means a vector A is a parallel to vector B. Here sine 0 is 0. So, therefore, we get A cross B, magnitude of it we get 0. Next, when theta is a 90 degree, vector A is perpendicular to vector B. Theta 90, sine 90 is 1, we get A cross B is equal to AB. You can even write like this, like AB sine theta and then that vector which you need to write. So, now out of this, which is minimum, which is maximum? So, this is minimum because it is a 0, this is maximum. Remember, this is exactly opposite of the previous case. In the previous case, we got the maximum value when theta was 0 and we get minimum value when theta is a 90 degree. But here, cross product is minimum when the vectors are parallel and the cross product is maximum when the vectors are perpendicular to each other. Hope you understood the difference between the two types of the product. One is the dot product, the other is cross product. In dot product, when you multiply two vectors, you will get a scalar quantity, whereas in cross product, when you multiply two vectors, you will get again a vector quantity. Okay. So, let us see some questions related to it. A dot B is 0. What is the angle between A and B? So given A dot B is a 0. So what is the angle? See, A dot B is given by, dot product is given by AB cos theta. So for what angle we get a 0? So when theta is a 90 degree, cos 90 is 0. So that's why A dot B is 0. Therefore, answer to this question is what is the angle between A and B? The answer is 90 degree. Next, if A cross B is 0, what is the angle between A and B? A cross B is given by AB sin of theta and then unit vector, correct? And it's given that that's equal to 0. Okay. So for what angle we get sine is 0? When theta is 0, sine is 0 is a 0. So that's why the angle between the two vectors is 0 degree. So these are all 1 mark questions which you can answer them very easily. So next let's learn something again related to the vector, and it's about position vector and displacement vector. So to understand that, let's first consider a vector or a particle. So I'm going to consider a particle here at a position A. So the particle is here. And somewhere here I'm going to consider the origin, this is the origin. From this origin, I'm going to draw a vector to the position of the particle, okay. So I'm going to draw a vector like this. Now that is called position vector. The vector drawn from the origin to the position of a particle is called as the position vector. We represent that by R1 vector, okay. Now this particle moves to some other position, somewhere here, to B. That is a new position, okay. Again from the origin, from here, I will draw one more vector like this, okay, new vector, and I am going to consider that vector as R2 like this, new vector. So this is also a position vector. So what is a position vector? Vector drawn from the position of the particle, from the origin to the position of the particle. Vector drawn from the origin to the position of the particle is called as the position vector. This is the initial position, correct? This is the new position. Initial to final will be like this, correct? Yes? What do we call that? That's called displacement vector. So vector drawn from the initial position to the final position is called as displacement vector. What is the value of the displacement vector? Let that vector be x, okay. So now I can use a vector addition, vector R1 plus x is equal to vector R2. This is from the triangle law of vector addition, where I am going to take a vector, I will add with this vector, this will be the resultant. So from this, what is x? This x is equal to R2 minus R1. So that's what we get. So this vector, displacement vector, will be R2 minus R1, okay. So what is position vector? Vector drawn from the origin to the position of the particle is called as the position vector. And what is displacement vector? Vector drawn from the initial position to the final position is called as displacement vector. So hope you have understood the vector. Now any position vector we can represent like this in the form of an equation, okay. R is the symbol used, okay. Vector R is equal to x I cap plus y j cap plus z k cap. So you are already familiar with the I, z, k. So these are the unit vector along x axis, y axis and z axis, and these are the components along x axis, y axis and z axis. This is the position vector, okay. And how to find the magnitude of this position vector? In the last class I have given root of x square plus y square plus z square. I will differentiate this position vector so that I will get dr by dt. Rate of change of position will give you the velocity vector, which is v. okay, that is equal to d by dt of position vector is here x I cap plus y j cap plus z k cap. That is same as dx by dt I cap plus dy by dt j cap plus dz by dt, which is k cap. What is the dx by dt? Dx by dt is nothing but a rate of change in position along the x-axis, correct? Rate of change. And what is the rate of change of position gives? The rate of change of position gives velocity. So that's why this will be the velocity along the x-axis. This will be the velocity along y-axis. And this will be the velocity along z-axis. Clear? So that is how you will get that equation. Vector v is equal to dr by dt, which is vx I cap plus vy j cap plus vz k cap. What is vx, vy, vz? Vx is the component of the velocity along the x-axis. What is the vy? Component of the velocity along y-axis. And what is vz? Component of the velocity along the z-axis. So that, how to find the magnitude of that? Root of vx square plus vy square plus vz square. This is how you can find the magnitude of the velocity. I hope you understood. Now, if I take dv, further if I differentiate, dv by dt, then I will get the acceleration, because acceleration nothing but rate of change of velocity. So, similar to the previous step, we get the acceleration vector, which is given by vector A is equal to dv by dt, which is ax I cap plus ay j cap plus az k cap, where what is ax, ay, az? These are the components of the acceleration along x-axis, y-axis and z-axis respectively. And how to find the magnitude of that acceleration? Root of ax square plus ay square plus az square. So, hope you have understood all the components here of the x, y and z. So, this is the position vector, velocity vector, and now the acceleration vectors. Again, we can understand this better with the two numericals. So, that is what I am going to explain next. So, go through the statement of the numerical. Okay. The position vector of a particle is given by vector r is equal to 3t I cap plus 2t square j cap plus 5k. So, this is the vector given, where t is in second, r is in meter. First option, find the velocity and acceleration of the particle. So, first let us find the velocity. How do you find velocity? Vector v is equal to differentiation dr by dt. That is a d by dt of 3t I cap plus 2t square j cap plus 5k. So, first here 3 is a constant, differentiation of t is a 1. So, we get only I cap plus differentiation of t square is nothing but 2t, 2 into 2, 4t j cap. This is a constant number. So, differentiation of this is a 0. So, therefore, we have found the velocity. So, this is the value of the velocity. Okay. This is anyway is a 0. So, we have found the velocity. How to find the acceleration? Acceleration is equal to further differentiate dv by dt. So, d by dt of the velocity. Velocity is here 3 I cap plus 4t j cap. Again, only a number constant, differentiation of this is 0 plus differentiation of t is 1, but 4 is there, correct, 4 into 1 and then 4 j cap. So, we have found the acceleration, acceleration is 4 j cap. So, it is a very clearly we can understand that the acceleration is along the y-axis. See, magnitude is 4, but the direction is given by the vector j, unit vector j, which is always taken along the y-axis. Let us see if there is any other option. Find the magnitude and direction of the velocity at t is equal to 1 second. Okay. So, the value of the velocity is here, this is v. We will find the magnitude of it. Okay. So, vector v, this is the second option, vector v is equal to, at t is equal to 1 second. So, 3 I cap plus 4 into t is 1, 4 plus 4 and then j cap. So this is the velocity. How to find the magnitude? How do you find the magnitude of two-dimensional vector? Square root of 3 square 9, 4 square 16, total 25 with the root. How much is that? 5 meter per second. So that is the value of the velocity. How to find the direction? The direction is given by tan. So tan theta is equal to always q by p. If I consider this as x, this as y, and it will be vy by vx. What is the value of vy? The value of vy is nothing but 4 here. So this is 4. This is vx. Okay, this is vy. So 4 by, what is vx? It's a 3. What is 4 by 3? 1.333. Okay. So from this we can write theta is equal to tan inverse of 1.333. So this is how we can find the direction of the velocity at time t is equal to 1. Okay. So hope you have understood. So this is from the case, when theta is equal to 90 degree in two-dimensional vector. Okay. We use the formula tan alpha is equal to q by p. So using that format we have used this equation in finding the direction. Okay. Right. So that completes one of the problem. So let's try one more problem. So hope you have again understood these kind of numericals. Only when you practice you'll be able to understand, and if you have any doubts, you are always free to clarify your doubts, provided you are interested to learn. Okay, right. So one more. The position vector of a particle is given by vector r is equal to 3t I cap minus 2t square j cap plus 4 k cap, where t is in second and r is in meter. Find the velocity of the particle and then the acceleration. Let's find the velocity. So to find the velocity, I have to differentiate. It's a dr by dt. That's a d by dt of r. R is this 3t I cap minus 2t square j cap plus 4k cap. First, 3 is a constant here. Differentiation of t is 1, so therefore we'll get 3 I cap minus t square. Differentiation of t square is a 2t. 2 into 2 is a 4t j cap. And then the differentiation of this is only a number, constant. Differentiation of that is a 0. Okay. So therefore this is the formula for the velocity. How to find the acceleration? Acceleration is again rate of change of velocity, dv by dt. So d by dt of the velocity is this 3 I cap minus 4t j cap. Differentiation of only constant 0 minus differentiation of t is 1, so we'll get minus 4 j cap. So this is what the value of the acceleration. So acceleration is equal to minus 4 j cap. So we have found the velocity of the particle, we have found the acceleration, okay, and now magnitude of the velocity at t is equal to 2 seconds. Here in this, let's find. So velocity v is equal to 3 I cap minus 4 into 2 minus 8 j cap. So how do you find the velocity? Magnitude square root of 3 square, which is 9, plus 8 square, which is 64. That's root of 73. So we can find the value of that, root 73. So root 73 is 8.544. It's 8.544 meter per second. So that's the magnitude of the velocity at t is equal to 2 seconds. Okay, again question from one of the examination for 5 marks. So hope you have understood the product of the vectors, the position vector, the displacement vector. So again study all this, because the topic becomes more difficult here onwards, and more concepts are there. So that's why unless you study on daily basis, it's not possible to study this entire chapter for the coming examination. So I'm going to continue more about this particular chapter in the next class. Thank you.